On August 6th, 1945, the atomic bomb nicknamed Little Boy was dropped onto the city of Hiroshima in Japan by the American bomber craft Enola Gay. 3 days later, a second atomic bomb called Fat Man was dropped on Nagasaki, finally forcing Japan to surrender to the American forces, and brought an end to World War II. It is estimated that over 180,000 Japanese citizens were killed by the two bombs. This new, incredibly powerful weapon changed the course of history forever, putting the world on track for the Cold War and eventually leading to the development of a new clean power source. But where did this begin, truly? For that, we must go all the way back to 1932. The true starting point of nuclear science was in May 1932, when the neutron, one of the fundamental parts of the nucleus, which is at the center of every living cell, was discovered by a British scientist. The discovery of the neutron was pivotal for the events that would soon transpire. Only a year after that, a scientist named Leo Szilard thought up the idea of using neutrons and nuclei to create a chain reaction of atomic energy. A lot of the details for how it would work are murky or best, and suffice it to say that Szilard would not revisit the idea for a long time. Later, in 1934, a 33-year-old Italian scientist living in Rome named Enrico Fermi conducted an experiment with his students where they launched neutrons at different materials in an attempt to make them radioactive. One of these materials was uranium, and as the material was already radioactive, it was unclear what had happened to them, but Fermi knew something had happened, as its mass had changed. Later that same year, a scientist named Ida Natick published a paper claiming that the uranium atoms had split somehow, although her claim was discredited by the scientific community as she had no authority on the subject. 4 years later, in 1938, a pair of German chemists launched neutrons at uranium, as Fermi had done, except this time they managed to detect barium, another element, afterwards. Although this process had no name at the time, today we have coined it fission. A year later, a 34-year-old Harvard graduate named Robert Oppenheimer hears about the discovery of fission and has an epiphany. Every material has a set amount of neutrons in it, except for a select few, which includes uranium. If the uranium had split into different materials, some of the neutrons must be emitted as excess. These neutrons might hit other uranium atoms, which would split into different materials and give off neutrons, and so on and so on. Oppenheimer realized that the thermal energy released by the collisions could be used to create a bomb. Uranium is important in another aspect as well, in that it has 7 different isotopes. An isotope is a version of an atom that has more neutrons. Another scientist, named Niels Bohr, realized that only one of the isotopes that was actually usably fissionable was uranium-235, which made up less than 1% of all uranium, which is ironic, as it was still the second most common kind found in nature. This presented an obstacle for would-be bomb makers as how they would attain the uranium, and how they might separate it from the dominant 99% of uranium-238. In March of that same year, Enrico Fermi and a colleague find out that for every neutron used in fission, 2 are created. A little later, Enrico Fermi receives a letter from Leo Szilard about the possibility of putting small amounts of uranium into graphite blocks in order to cause a chain reaction while moderating it, so it would knock it out of hand. Then, a month later, Leo Szilard traveled to Long Island to seek the counsel of a very well-known scientist and an acquaintance of his named Albert Einstein. When he explained the possibility of using fission to create very powerful bombs, Einstein replied, "I did not even think about that." Szilard wrote a letter to the president warning him that not only might the bomb be possible, but that it was likely already being developed by the Germans, as just a while ago they had stopped selling the uranium coming out of their mines. Normally, the president would have ignored a letter from a little-known European scientist, but Szillard's visit had a purpose in addition to consulting possibly the greatest mind ever to grace planet Earth, as he knew no president in his right mind would ignore a letter bearing Albert Einstein's seal. Thus, the Einstein letter was sent and answered shortly, with President Roosevelt convening a meeting of a few respected scientists. Szilard was one of those few. It was there where work on the bombs began in earnest, as the committee decided to grant Leo Szilard and Enrico Fermi $6,000 to carry out their experiments, which is about $100,000 in today's money. And that was the day they unofficially started the Manhattan Project. Einstein's application to join was refused, as his pacifist nature could be a security risk. A month later, Germany invades Poland, starting World War II. After this, scientists started looking into ways to increase the amount of uranium-235 in natural uranium. One of the ideas, and the one that was eventually used, was gaseous diffusion. The numbers by which isotopes of atoms are labeled are their atomic weights, which shows the combined number of protons and neutrons. As you can see, uranium-238, the non-fissionable one, and 99% of natural uranium, has 3 more neutrons than U-235, the one we want. One very important thing to note is that uranium was not exclusively a solid, but also comes as a gas. Gaseous diffusion worked by funneling the gas uranium through an incredibly small tube into a slightly larger tank, with 2 exits, one just ever so slightly larger than the other. The U-235 went into the smaller tube because of its very slightly smaller size, and the U-238 mostly went into the other. However, some inevitably would get mixed up, so this pattern repeated itself over and over until almost all of the remaining uranium was U-235. None of this had been tested yet, however. Currently, this was all just plans and research. Little other work was carried out for the first few years, as researchers battled just to get funding. Soon enough, the scientists finally get started on building the graphite-uranium combination originally suggested by Szilard, although Fermi conducted most of the experiments at this point. Robert Oppenheimer takes charge of much of the necessary research and establishes himself as a natural leader. Things are still much too slow until the bombing of Pearl Harbor, where the Manhattan Project finally picks up some speed. In 1942, Fermi relocates to the Chicago Met Lab and builds a much better nuclear pile, as the last one was too impure to use. On December 2nd of that year, the nuclear reactor known as Chicago Pile 1 went critical. The pile was not what one would expect a nuclear reactor to look like, but nonetheless it worked, and it became the world's first nuclear reactor. Both Fermi and Szilard are present. Later, Robert Oppenheimer becomes leader of neutron research. Because some senators are upset with how slowly the project is moving, Colonel Leslie Groves is made aware of his new position as leader of the Manhattan Project in September 11th and returns from his overseas job managing tens of billions of dollars. Only a day later, he immediately buys over 1,000 tons of high-quality uranium for research purposes. After looking for a place to house the entirety of the Manhattan Project, he decides that a spot in East Tennessee was perfect for his needs. He needed a place that would be able to work unnoticed, which he would be there. It had enough people to employ, but not too many because someone might let something slip. It was planned for the site to contain all possible enrichment facilities, as it had enough land and water for their needs, along with rather cheap land at under $60 per acre. This facility was very secretive. Very few people knew the full scope of the operation, and workers were only informed of things relevant to their duties. This happened only a day after he bought all the uranium. We can say with certainty that he was not selected for his tendency towards hesitation. After having made an impression on the colonial for his natural leadership skills, Robert Oppenheimer is selected to head an unnamed project in New Mexico, and in December of 1942, construction for the site starts. In 1943, after the unnamed site's construction is nearing completion, staff start relocating there. In January of 1944, Robert Oppenheimer and General Groves authorize a bomb test to be scheduled. At Oak Ridge, plans for the gaseous diffusion plant are made in late May, and in June, construction for it starts. However, major delays in shipment of materials force it to remain unbuilt until January of 1945. Soon after it is built, the scientists procure enough 235 uranium for the bomb test to go forward. On July 11th, construction of Gadget, the world's first atomic bomb, begins in anticipation of the Trinity test, which has experienced numerous delays because of the failure of practice equipment due to overuse. The bomb's construction is completed 2 days later. On July 16, 1945, the atomic bomb, Gadget, is detonated in the middle of the desert in Los Alamos. The explosion is felt in neighboring cities, hundreds of miles away. There, Robert Oppenheimer famously said, "Now I am become death, the destroyer of worlds," a quote from the Hindu Bible. Just 15 days later, on the island Tainan, off the coast of Japan, Little Boy would finish construction. Fat Man would follow it just a few days later. On 1945, August 5th, the crew of the newly christened Enola Gay are briefed on their mission. They successfully drop Little Boy onto Hiroshima. Seeing no signs of surrender from Japan, American planes start distributing threatening leaflets over cities saying they could be next. When that doesn't work, another bombing is scheduled on August 9th. The target is Kokuru Arsenal in Nagasaki. On August 9th, however, the fog is so dense that the pilot cannot see his target. Enemy planes force him to abandon the search for it. He spots a single break in the clouds, showing the city of Nagasaki, some kilometers away from his target. He doesn't have enough fuel for another attempt, so he takes his chances and launches the bomb. It hits, and on 1945, August 14th, Japan surrenders to the U.S. World War II is over. Although the members of the Manhattan Project would never forget their time there, they went on with their lives after the bombs. Leo Szilard continued his scientific career after the bombs and switched his focus to biology. He was involved with the first ever cloning of a human cell and violently fought against people who would abuse nuclear power. He would die of a heart attack in 1964. Enrico Fermi would step back from the science scene later, but numerous things were named in his honor, such as the prestigious Fermi Award, the Enrico Fermi Academy, and even the element fermium after his death, which occurred in 1954. Robert Oppenheimer went on to make contributions to the future of quantum mechanics and was the first person to think of quantum tunneling. He was stripped of his access to the successor of the Manhattan Project in 1954 due to the fact his brother and wife were both communist, and was branded an outcast by the scientific community. Enrico Fermi was one of the few scientists who testified in his defense. President Kennedy, ironically, presented Oppenheimer the Enrico Fermi Award after Fermi's death and used it to reintegrate himself into the science scene. He died in 1967. General Groves, funnily enough, was in no rush to hurry into his grave and outlasted all of the other scientists. He retired a few years after the project, but before his retirement, he was made a lieutenant general for his work developing the bomb. He died in July 1970 and was put to rest beside his brother. In time, other countries would start developing bombs as well, but to date, the only nukes to ever see combat use were the ones dropped into Japan. They did end World War II, stopping any more American casualties, but at the cost of 180,000 Japanese civilians. Nuclear reactors eventually became a new clean power source, and yes, there has not been another all-out world war because of the so-called nuclear deterrent, but it is now completely possible for humanity to absolutely and totally obliterate itself with the push of a button. The only thing left to ask is, was it worth it? And that's a question you'll have to answer for yourself.